Man's curiosity is as limitless as the universe. We can now study very distant galaxies, planets, and celestial phenomena thanks to many space exploration programs and technological developments such as telescopes, satellites, and space probes. Our understanding of how the universe works is expanding, allowing us to forecast what is conceivable. However, in an unforeseen turn of events, scientists have discovered an extraordinarily powerful cosmic ray that has just hit Earth and they have no idea where it came from. Is this some random cosmic occurrence? And what can be done to address it? Stay tuned as we get into the specifics. Hello and welcome back. You are watching Zeey, the Space Fanatics. Subscribe to our channel and ring the bell so you don't miss any of our daily videos. The discovery. The unknown cosmic ray, extremely high-energy space particle falling to Earth, was discovered by scientists using a large telescope in Utah's West Desert. They named it Amaterasu after a Japanese sun goddess. This particle contains more energy than any other cosmic ray ever discovered. These ultra-energetic particles are typically created by massive cosmic events far larger than a star bursting. However, Amaterasu appears to have arrived from the local void, a peaceful region near our Milky Way galaxy. Professor John Matthews of the University of Utah, who assisted in the finding, says it's a mystery because nothing in its path is highly energetic enough to make it. Amaterasu contains more energy than 240 ex-electron volts, which is far greater than the Large Hadron Collider, the world's most powerful particle accelerator. It's comparable to the energy of a golf ball traveling at 95 miles per hour. The Oh My God particle, discovered in 1991, was the only cosmic ray with larger energy. When Toshihiro Fuji, a Japanese academic, first discovered Amaterasu, he was taken aback. He suspected a mistake because it had more energy than anything seen in the previous 30 years. Scientists believed that such high-energy particles could be produced by a massive black hole in the center of another galaxy. Matter breaks down into small pieces near these huge black holes, and protons, electrons, and nuclei are propelled out into space at breakneck speeds. Cosmic rays like the one they discovered are constantly raining down on Earth as a result of these extreme cosmic events. Mysteries of Amaterasu. Particles with little energy bounce around like a ball in a pinball machine due to electromagnetic forces in space. However, superenergetic particles such as Oh My God or Amaterasu do not follow this pattern. They should travel through space without bending due to magnetic forces, allowing them to be tracked back to their origin. When scientists try to track these particles' paths backwards, they end themselves in space. The source of the Oh My God particle was similarly unknown. Scientists believe this could indicate that magnetic fields bend more than predicted, something unknown in the empty space adjacent to our galaxy, or that they don't fully grasp how high-energy particles work. According to University of Utah professor John Bells, these particles originate from many locations in the sky. It's not as if there's only one enigmatic source. It could be due to difficulties with the structure of space and time, or collisions between cosmic strings. When did these cosmic rays first become known? Cosmic rays are very energetic microscopic particles that travel through space at nearly the speed of light. They are essentially just proton atomic nuclei or clusters of protons and neutrons. While many come from the sun, some arrive from sources outside of our solar system. When these rays collide with the Earth's atmosphere, they produce showers of other particles, both positive and negative. Victor Hess discovered cosmic rays in 1912 by ascending in a hydrogen balloon and using an electroscope to analyze radiation in the atmosphere. He discovered that the ionization rate was substantially higher than at sea level, validating a theory that this radiation was emitted by Earth's rocks. The tracks left by cosmic rays look like wispy white lines, akin to tiny jet contrails, if you've ever seen a cloud chamber in a scientific museum. The energy levels of cosmic rays vary, with the least energetic being the most prevalent. These are the ones Hess discovered and will most likely be viewed in a museum's cloud chamber. Scientists proposed a theoretical limit for cosmic ray energy in 1965, no more than 50 exa-electron-volts from more than 300 million light-years away from Earth. This is due to the cosmic microwave background radiation, which was identified in 1964 as the glow from the Big Bang. Any cosmic rays that travel further would be annihilated by interactions with the CMB before reaching Earth's detectors. The GZK cutoff is named for the scientists that proposed it, Kenneth Greason, Georgy Zatsepin, and Vadim Kuzmin. Even till 2023, the Oh My God particle discovered in Utah in 1991 is the most intense cosmic ray ever seen. It had an extremely high energy level of 32 ex-electron volts, which surprised scientists and called into question their understanding of where cosmic rays come from and how they move. This unique particle appeared to come from the Perseus constellation in the northern sky and impacted Earth's atmosphere almost at the speed of light. It had the energy of a bowling ball dropped from shoulder height, yet it was compressed into a microscopic particle. We don't sure what kind of particle it was, but most cosmic rays are protons. The Oh My God particle moved nearly as rapidly as light, and if a photon followed it, it would take about 215,000 years for the photon to be just 1 centimeter ahead, as seen from Earth. This is because to particular restrictions governing how fast things may move, known as special relativity. The energy of the particle was 40 million times greater than the highest energy protons in any human-made particle accelerator. However, when it collided with a nitrogen nucleus in Earth's atmosphere, only a small portion of its energy interacted with the nucleus, with the majority being converted into the movement energy of the particles that emerged from the impact. When the Oh My God particle collided with a nitrogen nucleus, it created 29 exa-electron volts, which is far higher than the Large Hadron Collider's maximum collision energy. In layman's words, the collision created particles with a lot of energy that moved almost as rapidly as light. The Oh My God particle possessed 10-20 times the energy of visible light photons, equivalent to a baseball weighing 142 kilos and traveling at around 28 meters per second. Its energy was 20 million times greater than that measured from a faraway object known as the Blazar Markarian 501. Even though this particle possessed a tremendous amount of energy, it was 40 million times less than Planck's energy, which is required to grasp the most minute details of the universe. If a proton had the same energy as the Oh My God particle, it would have to be 1.665 pence faster than light. From Earth, it would take around 357 octa-years for a photon to pass a proton with Planck energy, which is a long time. Since then, scientists have yet to discover another particle like the Oh My God particle, but they have witnessed other high-energy events. The origin of cosmic rays. Where do these light-speed cosmic rays come from? Even the most powerful supernova can't create them. One theory is that they are caused by massive explosions in space, such as when a black hole rips apart a star, releasing a massive jet of superhot material. Particles pass through magnetic fields numerous times as they travel through space, gathering up more and more energy. Active galactic nuclei, which are often found in the center of galaxies and are thought to contain a supermassive black hole, are another possible source. AGNs fire intense jets of extremely hot material, causing shock waves. Some scientists predict gamma-ray bursts or hyper-intense places where stars emerge, dubbed starburst galaxies. The tough issue is that the pathways of these rays get distorted by magnetic fields on their trip to Earth, making it hard to figure out where they came from in the sky. In 2017, astronomers thought they identified a couple of interesting places, one in Centaurus A and the other in a galaxy called M82 in the Ursa Major constellation. However, the confidence in the Centaurus A site has declined since 2019 because fewer cosmic rays seem to be coming from there. How do we track these cosmic rays? Around the world, a set of observatories is committed to spotting and analyzing mysterious particles in space. Scientists are interested to understand where they come from and the extraordinary processes that make them. One of the important actors in this initiative is the telescope array, positioned strategically in Utah's West Desert. This is no tiny setup. It has over 500 detectors organized in a square grid covering 270 square miles. Its major purpose is to identify cosmic rays, which are superfast particles. Placed at 1,200 meters, the telescope array permits secondary particles to form before breaking down. Its location in Utah assures dry air, necessary for clear detection and dark sky to avoid light pollution. The current design, known as ATA-42, has a 300-meter baseline, and there are plans to expand it to ATA-350, which has a 900-meter baseline. Each antenna has a cooled log periodic feed that is effective from 1 to 10 GHz. The telescope array has the capacity to generate up to 32 phased array beams, making it suited for large surveys. The Pierre Auger Observatory in Argentina is another important actor in cosmic ray observation. With a total area of 3,000 square kilometers, it is the world's largest cosmic ray observatory. The Pierre Auger Observatory intends to solve the riddles of UHICURS by using a large array of detectors. The high-resolution FLIES-I project, like the telescope array, was located in Utah and employed fluorescence detection to investigate air showers caused by cosmic rays interacting with the Earth's atmosphere. Although HIRES is no longer functioning, its valuable dataset has greatly contributed to our study of these high-energy particles. Auger Prime is an improvement to the Pierre Auger Observatory that aims to improve the precision and efficiency of cosmic ray detection. This demonstrates the continued commitment to improve existing observatories' capabilities for more accurate observations. The Tunka Advanced Instrument for Cosmic Ray Physics and Gamma Astronomy Observatory is a major actor in cosmic ray research in Russia. TAIGA actively contributes to the study of cosmic rays utilizing detectors such as water Cherenkov detectors, despite its primary concentration on gamma-ray observations. Another site with dual capabilities is the Southern Wide-Angle Gamma-Ray Observatory in Puebla, Mexico. While its primary aim is to observe gamma rays, SWGO is intended to make important contributions to the study of cosmic rays by employing a water Cherenkov detector array. Despite these observatories' advances, analyzing cosmic rays remains difficult. Magnetic fields impact the courses of these particles, making it difficult to track their origins in the sky. Scientists must assist in understanding observations such as cosmic rays arriving from various directions with no obvious explanation. Recent discoveries, such as the Amaterasu particle discovered by the telescope array in 2021, add to the enigma. Amaterasu, like the famous Oh My God particle in 1991, shocked scientists because its origins could not be determined. They discovered a local void space near our Milky Way galaxy by following its route. Because magnetic fields should have little effect on these high-energy particles, scientists expected to find their source. However, the Oh My God particle and Amaterasu must have been created by something high-energy in the traced path. The telescope array is growing, with 500 more detectors planned to cover 1,100 square miles. This extension could assist scientists in detecting more of these mystery high-energy occurrences and even understanding where they originate. The odd thing is that these events appear to come from different places of the sky, making it difficult for scientists to discover a precise explanation. Because established explanations do not fit, others propose alternative concepts such as faults in space-time or colliding cosmic strings. With its ongoing expansion, the telescope array aspires to uncover a real enigma. What are your thoughts about Amaterasu? What do you think caused it? Let's hear from you in the comment section. Also, like this video and subscribe to this channel for more.